Um, okay. So what are we doing today? We're going to talk about math. We're going to talk about calculus. Um, I'm going to ask you some questions to get us reoriented to where we are in the class. And then I'm going to throw you into an activity. I sent an announcement out through Canvas about it. So maybe you've taken a look at it. Maybe you haven't. You don't need to. I will tell you what to do and introduce you to um, what we're going to do. And in my 8 o'clock class today, it was pretty much all we did. We started with some review at the beginning, and then my class basically just worked on this for the rest of the time. So I expect that that's what we're going to do today. But I'll get a sense of that as we're working and as I'm going around the different groups. So let me make Cynthia a co-host so she can move around between groups too. And let me turn on my iPad. And share my iPad while we talk through announcements and info. All right, it's trying to share. Okay, it's sharing. So we're 7 oops, that seems a little fat. 7 of October. This is Calc 1. All right, grade reports have not gone out yet. So if you feel like I might have overlooked you, don't worry about. I did not overlook you. I overlooked everybody. So they haven't been sent out yet. They're on my list of things to do. I've got some learning target quizzes I need to grade. So thank you for your patience. I'll be getting to those soon. Yeah. Other than that, I don't think there's anything crazy happening in the class. We're just doing what we normally do. Cynthia, do you have any announcements? Anything you want to say to the group?
Not that I can think of at the moment.
Okay. Yeah, okay. Anybody else have any questions or comments, things they want to share with the group? Everybody's good? I'm trying to get the gallery view open here so I can see everybody's names. Yanni's giving the thumbs up. Seems like we don't have many people. 19. Yeah, there should be more of us here. Well, they're going to be crying. Vice presidential debate tonight. If you're by TV, you can watch it and hope it's different from the presidential debate we had the other day. All right, I think it feels like we're all ready to talk about math. So I'm going to ask everybody a question, and you can answer either verbalize it or throw it into chat. I'm going to ask you, what are we talking about these days? What is the topic du jour? What are we trying to learn?
Differentiability.
Yeah. Differentiability. That's a good word for it. That's what we're trying to learn. We're trying to wrap our head around it. Okay. When somebody says the word differentiability, and who was that? Was that you, Cyrus? When Cyrus says the word differentiability, what other words or phrases does that call to mind? Yeah, Elizabeth says math in the chat. Yes, Elizabeth, you're right. It's math. Funny. It did make me smile. Eduardo, what did you say?
Continuity.
Yeah. So last time we learned that if a function is differentiable, it has to be continuous. So continuity is tied up in that. And there's a whole lot of geometry. And I think about graphical representations of functions, a whole lot of geometry we associate with continuity too. And so there's going to be some geometry we associate with differentiability as well. What's another word that comes to mind when somebody says differentiability? Anybody?
talked about graphs a lot yesterday.
Yeah. We talked about graphs. How did we use graphs? What's one way we used a graph, Joseph?
You talked about an easy way to figure out if it was differential by if the graph was a smooth line or not.
Yeah, right. So this is that connection to the geometric idea of differentiability. That a function is differentiable if its graph is smooth. And when we say smooth, we really mean no points. Or no place where it's sharp. So yeah, definitely we talked about that. What's another way that we use graphs when we talk about differentiability? Anybody? Or what's another idea that comes to mind when we say the word differentiable? Nothing?
The concept of limits.
Uh-huh. Absolutely. Oops, let's do this in black. How are limits involved in differentiability? Are they? Or are we just nerdy when we say the word limit?
When we're calculating the slope of a point on a curve, I guess we say that we're calculating the slope as the limit of delta x gets to closer and closer to 0.
Yeah. So we're not. So I'm going to be pedantic. I'm going to be that guy that it's going to come off as a little maybe critical or jerky, but it's you Cyrus, you said some things that a lot of students say, and it's natural to say it these ways when we're learning the vocabulary. You said the slope of a point. Well, points don't have slope, it's lines. We're calculating the slope of a line. And it's the slope of a line at a point, okay? So I'm gonna write down slope of a line, well, a specific kind of line, a tangent line, at a point of tangency. Okay, that's what we were calculating. And we're gonna call that point of tangency, give it coordinates, x naught, comma, f of x naught. And we calculated that slope as a limit as a delta x goes to 0. You're absolutely right about that, of the slope of secant lines that go through x naught, comma, f of x naught, and x naught plus delta x, comma, f of x naught plus delta x. So this is a super important idea that's associated with differentiability. In fact, it's the defining idea for differentiability. A function is differentiable if this limit exists. It's differentiable at this point of tangency if this limit exists. Okay. And okay, so super core important idea. I'm going to swipe over to the next page. So we did something like this. We said if f is differentiable at x naught, we can define a rule that takes x naught to the symbol we're calling it f prime of x naught, right? So this is new notation for us. Okay, part of the notation reflects the function it came from, so there's the f there, and then we add in this prime notation, and then we retain x naught because we're defining the value of a new function here at this input. And this rule that takes x naught to this new thing. This new thing is the value of that limit. Okay. And we call f prime the derivative of f. Okay. So this rule here we're defining is called the derivative, okay, or differentiation. And it's a process that takes us from a function f to a new function f prime. Okay, that process called differentiation. And this, so this, the point I'm trying to make here is that f prime is a new function. And we get it from this. And today, our activity is going to give us some time wrestling with the idea that this is the slope of a tangent line. At the point of tangency x naught, comma f of x naught. Okay. So this is what we've been talking about so far. The next item on our agenda to talk about with respect to differentiation and derivatives are other ways to calculate this. This is kind of hard to calculate. There's lots of algebra in that secant line and limits. They're a little touchy. Well, I'll present to you some other ways to calculate these derivatives. But for today, I want us to spend some time getting comfortable with this idea. Does anybody have any questions about this stuff that we've been talking about? I want to ask it while we've got a minute. No questions? Okay, so let's move on to this activity that we're going to talk about today. So I need to find a browser that has the assignment in it. And so I want you to take some notes about this. So I'm going to share my browser. Here we go. So you should see my browser, and it has our Canvas page on it. And here's the announcement that I sent out this morning to our class. Here's a Google Doc. I'm going to click on the Google Doc, and this is the instructions for today's activity. Okay, so what I'm going to do in a few minutes after we get done with this intro is I'm going to send us all into breakout rooms. And I'll let Zoom do it. It'll all be random. We've got 19 people, 19 people here right now. And so I'll probably make 7 breakout rooms. So there might be one group of 2. So groups of 2 and 3. So you're going to get into this group. And the first thing you're going to do is one of the people in the group is going to go to this link here in this Google document. And actually, I'm going to put this in the chat so everybody has it and nobody has to find this Google Doc. So, So here's the link to the Jamboard, but I'm also going to give you a link to these instructions because you probably will want to refer to them. Okay, so instructions. Okay, so there's a link to the instructions. So the first thing you do in your group, one person goes to this Jamboard and makes a copy. And I'll show you how to do this in a second, but there's a little image here that shows you that in the Jamboard, there's a little menu up to the right, the top right corner. You click on it and there's a choice for make a copy. So you make a copy of the Jamboard and you'll share that with your group. Okay. And then once you share that with your group, you're going to work on this together in a browser with members of your group. And each of you can interact with the Jamboard and make changes at the same time that other people are making changes. It's kind of nice, kind of neat. And then what I'm going to do is, as Cynthia and I go around, we're going to want to look at your work and sort of give you some feedback or ask or answer questions about the work. So we're going to want to see the Jamboard. And so you're going to need to make it available to us too. So I'm going to now. So here's the Jamboard. You should see this in my browser. When you share the Jamboard, so I'm clicking on the share button in the top right corner. One way you can share your Jamboard with everybody in your group is have everybody put their email addresses here or however they log into Google. And that's the way a lot of folks did it in my 8 o'clock class. Another way you can do it is you can, down here on the Get link, you can click on this and change this. So right now I'm sharing this Jamboard with anybody at CI who has the link, and it gives them permission to view. As soon as they make a copy, they're the editor, they're the owner. So when you make a copy, you'll be able to edit. I think this is a nice setting to have. And if you change the settings, the sharing settings to be like this, when you make your own copy, it will allow Cynthia to come and see your Jamboard when you share your URL with her. It'll allow me to see your Jamboard when you share the URL with me. Okay. So just be aware that this is a nice, efficient way to share your Jamboard. I don't want to change anything, or I don't expect Cynthia's going to want to change anything. But if you want us to interact with you, you can change viewer to editor. Okay. If you want to be more restrictive and make sure somebody doesn't accidentally come in and affect your work, you can share it with specific people in groups. I'm going to put the email address that I use for sharing Google things in the chat. So if you want to share it with me as an individual, use that email address and it'll allow me to access it. And then I'll let Cynthia put her email address in there that she would like used if she wants to do so. Okay, so I'm talking about throwing you all into the breakout rooms. Somebody goes and makes a copy, and then they'll share it with the other people in their breakout room. And then I'm here giving you some more details on what it means to change the sharing settings effectively. So let me go back to the instructions. So once you've shared your Jamboard with your group mates, okay, then here's the instructions for the activity. Right, so I'm going to walk you through the activity by looking directly at the Jamboard. You can read these instructions if you want. So where is my Jamboard? Sorry. Okay, here's my Jamboard. So up here in the top center, this is the frame bar. So this Jamboard has 9 frames. One of them is extra. There's really just 8 frames. If I click on this, you'll get little thumbnails of what's on each frame. Each frame consists of the graph of a function drawn in blue on a coordinate axis that has grid marks. The first 2 graphs are graphs of quadratic functions. The third graph is a linear function. And then as you go deeper into the frames, here's a cubic, here's another cubic. This looks like it's either 1 over x or an exponential function. Here's a piecewise defined function. Here's a function I say is sigmoidal. So different graphs of functions that have different properties. So your job is to, as a group, is to work on these graphs and start plotting points of the derivative of the function that's graphed. Okay, that's your job. And this is how you're going to do it. Okay, and I will erase my work in a minute. So you're going to use the mark. This is what I would recommend. Use the marker tool, okay, and come in and pick some input points. I'm going to pick a point. Let's pick a point right here. Let's pick -1. So it's a nice input value. So I'm going to choose a point of tangency right here. And I want to estimate the slope of the tangent line at this point. So I'm going to come down here and click. Oop, I need the selector. I'm going to select one of these lines down here. These are graphics you can use for your tangent lines. So you can select it with the arrow tool and drag it to where you want. And then over here, when you've selected it, in the top left corner, you can see a dot that has a little arc with arrows on it, ornamenting that corner dot, the top left dot. You can click on that top left dot and rotate the tangent line. Okay, so what you want to do is you want to rotate it just enough so it's pointing in the correct direction to be the tangent line at the point of tangency you've chosen. So that's pretty good. Now with this line, with this tangent line drawn, you want to estimate its slope by using the grid lines that are in the picture. And then when you estimate the grid lines, that gives you a slope of the tangent line, and then you use that to plot the point that's on the graph of the derivative. Okay. And so I would recommend you use a different color. So I'll use blue. And I haven't done the calculation, so this is probably wrong, but I plot the point there for the graph of the derivative that corresponds with the same input as the point of tangency. So it's going to be on the same vertical line, but it's going to have a different value in the y-axis. Okay. And then once you do that for one tangent line, go pick another point of tangency, grab another line down here and turn it into a tangent line. Estimate its slope, plot the point of the derivative, rinse and repeat. Okay. So that's the assignment. That's the activity, to use the tangent lines I give you to plot points of the derivatives of the graphs in the Jamboard. I recommend you can start wherever you want as a group. I recommend that you start with a quadratic curve and get a feel for how the tool works, get a feel for how the computations work. And then after you do a quadratic curve, choose another curve, maybe a cubic curve, okay? Or maybe the other quadratic curve. Let me go back to the Google Doc. I want to point out in the instructions here to the Google Doc, it basically goes through everything I just told you verbally, but it is more specific about the points that you're using. So x comma f of x is the notation for the point of tangency in the instructions. And then I tell you specifically how to find the location of the point that's on the graph of the derivative. Okay, so if you've got some confusion about that, look at the instructions. But in our warm-up conversation that we just had about the topics of differentiability, I also talked about where that point is or how you plot that point. Okay. So let me just repeat. I'm going to throw you into breakout rooms. Somebody is going to make a copy of the Jamboard. She will then share that Jamboard with the other people that are in the group in the breakout room, and then share it with me and Cynthia too at the same time. So when we come and visit, we can see your work. When you the members of your group are active and can access the Jamboard, start putting down lines as tangent lines, estimating their slope, and then plotting the point on the derivative. And then what'll happen is when you get 4 points plotted, you might see them falling into a pattern. All the blue graphs that I've given you are graphs of elementary functions. And it turns out that you take a derivative of an elementary function, you're going to get an elementary function back. So I think you can tell from the learning target quizzes and the way I talk in class that having a good understanding of the elementary functions is important, and being able to recognize their graphs is important. And here you're going to have another opportunity to look at these points, and they're going to be telling you a story of that they're an elementary function. And you can look at those points and maybe figure out what elementary function they're trying to sketch out. Okay. So after you get the 4 points that plotted, a good conversation to have with your breakout group mates is what does the graph of the derivative look like? What kind of elementary function is it? It's not part of the assignment, but that's a good conversation to have. I strongly recommend that you and your group talks about what you're doing. You give each other feedback. You ask each other questions. Does this tangent line look okay? I mean, what do you think about this slope that I've computed? You can work in parallel. You can work separately, but you should definitely be coming back together and talking about things and verifying the work of one another. Each of you could be working on a different frame on this Jamboard at the same time as one another. So it's going to be easy for you to work separately, but I just want to remind you that it's important that you work together. It's important from a learning perspective. It's important from a social perspective that it's good to be talking. With that said, and I know I probably don't need to say this because you're really good at this, and I'm really proud of you for the way you do this. But when I throw you into the breakout groups, the first thing you should do is just introduce yourself to one another. Make sure everybody knows who's in the group. Turn your camera on for a few minutes so people can match faces to names. And then once you've met each other, then you can turn the cameras off and then get to work. But make sure you agree each other and introduce yourself to one another and make those connections. You probably won't have time enough to finish this today. At least my 8 o'clock class didn't. And you'll probably end up working with this group between now and Monday. So keep that in mind as well. Any questions before we begin?
Yes. Do we write the estimations on the graph itself?
You don't need to write down any numbers. You don't need to show me any calculations. I'm just going to be looking at the graphs. And so you probably want to do this with some scratch paper handy and do some calculations, but you're not going to have to show me any writing on the graph. You might want to show your teammates your calculations, but yeah. Does that answer your question?
Yes. Thank you.
Yeah, you bet. Okay. So Cynthia, you're a co-host, so you can pop around. I'm going to throw you all into groups now. It looks like we've got 18 people, so I'm going to make 6 groups. That's groups of 3. And I'm going to go around right away and make sure that each group gets stuff set up. I'll ask you to share the URL of your Jamboard with me. And then I'll come back around a second time to see if people have questions. Okay. All right. So here we go. Buckle your seatbelt. How does this work? Participants. Let me stop sharing, see if this breakout rooms. Here we go. I assign automatically 6 breakout rooms. Okay, so here we go. Good luck.